Now let's talk about aggregation queries in MQL. Aggregation queries in MQL are expressed using pipelines with multiple stages. Each stage contains an operator along with its arguments. We have seen some of these operators before. For instance, filtering, which is called match in MQL, projection, sorting, and many others. Each stage takes in a collection of documents, computes its results, and passes the output to the next stage, if any. Here is a pipeline with 5 different stages. To construct a pipeline, we call the aggregate function and pass an array of operators to it. Since JSON documents are ordered, therefore the order of operators determines the order of execution in the pipeline. For the next example, we'll use a zip code dataset consisting of cities, states, and their associated data. Here is an example of constructing an aggregate pipeline. In this query, we want to find the states with greater than 15 million in population and sort them by descending order. We construct the pipeline by first calling the group operator and state that we want to group by the state field and compute a new attribute called total pop by summing the population field in the input documents. Notice using the dollar notation here on the right hand side to denote that we are referring to the attribute named state and pop and not the string literal. We then add a match operator to filter those states with our desired population. And finally, we add a sort like we discussed before. In SQL terms, the group operator performs the group by. The sum operator performs the aggregate, and the match afterwards performs the grouping clause. This constructs a 3-stage aggregate pipeline, which, when executed, will return the states of interest. And in SQL, this corresponds to an aggregate query with having an order by clause. The general form of the grouping operator is as follows, where we state the expression that we want to group by along with any aggregate functions. The aggregates are the usual ones that we are used to from SQL, along with a few MQL specific ones. Next, I want to highlight the unwind operator in MQL. Unwind expands an array by making each element its own document, kind of like flattening in Python if you are familiar with it. Unwinding is one of the operators in an aggregation pipeline, and we specify the field that we want to flatten by. For instance, back to the example of paper products earlier. When we run this unwind query, we will create new documents for each element in the tags array. And we follow that new document collection with a projection that removes the in-stock quantity. So we'll get the following objects if we pass in this document as input. Notice that the tags field is now a single string in the output rather than as an array as in the input. Obviously, we don't have such an operator in SQL thanks to the first normal form. Finally, let's talk about update queries in MQL. MQL has a number of data modification operations, and each of these operations can affect one or many documents. For instance, we can insert multiple documents by calling the insert many operation. Running this query will create a new collection called inventory if it doesn't already exist. And we will add the underscore ID attribute as the first field if it is a new document. And here in this update query, we change only those with the first dimension less than 15 and set their statuses to be invalid. This is similar to the update set where query in SQL.